All right, hello everyone and welcome back to these amazing math videos. Today we are going to be doing inverse for tangent and cotangent. All right, so first we're going to start by graphing tangent and cotangent, then we're going to talk about their restricted domains, just like all of our other inverse trig functions have had that restricted domain. Then we're going to do just a quick review at all inverses and then a couple practice problems. That's what we're doing. Here we go. Oh, let me move my head. Okay, I'll put me down here. All right, so first we're going to start by graphing tangent. All right, so let's just go ahead and, yeah, let's just do it. Okay, this isn't what I wanted. Hold on, let's pause. Okay, sorry, I had to change those tables because I did not want those numbers in there. I must have copy and pasted the wrong tables. Okay, doesn't matter. Anyways, here we go. So, like I was saying, we're gonna go ahead and we're gonna start by filling in our table values for our tangent graph. So at -90, tangent. All right, so just to look at our coordinates, right? -90, that is, let's also zoom in a little bit. View, zoom in, there we go. Now you can see a little bit better. All right, so at -90, so that's the same as 270, all right, our coordinates are 0, -1. Tangent is y over x. So when we do y over x, we get -1 over 0, which is undefined. All right, -45, so this is √2 over 2, -√2 over 2. All right, when we do y over x, we end up getting -1. At 0, our coordinate is 1, 0. All right, when we do y over x, we get 0 over 1, which is 0. 45 degrees is positive √2 over 2, positive √2 over 2, which simplifies to +1. And then 90 degrees is 0, +1, which when you do y over x is undefined. All right, so if we're sketching our tangent graph using these points, so here's our thingy. We have 1, 2, 1, 2, and we have 1, and we have 1. All right, so that's 1 up, that's -1, just so we can kind of see it a little bit better. All right, we have -90, -45, +45, and +90. Well, sketching in our graph, we're going to add in our asymptotes. So this is one period of tangent. Now, normally we start our first tangent graph at 90 and go forward. That's because it's easier to do that when we're doing when we're making up our periods, to just start at 90 and then go forwards rather than start at 90 and kind of go backwards to get our backwards period values. But for this instance, for our inverse, we're going to just pick this section, all right, because it's closest to the 0, 0, right? It's closest to the center. All right, so I have at -45, I'm down at oops, that's the eraser. I'm at -1, 0 is 0, and then 45 is +1. So here's my lovely tangent graph. I do the best I can. It'll pop up. There it goes. Okay, so here's tangent. Now, tangent does repeat, right? So we have another one that goes like that over on that side. We would have another one that goes like that over on this side, blah, blah, blah. So tangent, just like sine and cosine, it does repeat in both directions. Now, I don't want repeating values. I just want one full cycle of tangent that doesn't have anything repeating, just one full cycle of tangent. Well, luckily, tangent has its sections already figured out for you. You don't really have to do that much thinking to figure out where we're going to use our tangent values for our inverse. We're going to use this section right here from -90 to +90. All right. In this section, we have both our max and our min values, and it passes both a vertical line test and a horizontal line test. So our restricted domain for tangent is -90 to +90, which is the same as our sine and our cosecant functions. All right, so restricted domain, -90 degrees to +90 degrees. All right, so if we're thinking about our unit circle, right, we're right here, right? Here's -90, here's +90. This is quadrants 1 and 4. All right, so that is tangent. Now, I would love to tell you that cotangent was the same, but it's not. So we do have to do cotangent as well. So let's scroll over here and check out cotangent, because cotangent and tangent are different. They're going to have their asymptotes in different places. So for cotangent, all right, this is when we do x over y. So at 0, our, oh, my nose itches. Oh, there's like a hair. Okay, sorry about that. Okay, so at 0, we said our coordinate was 1, 0. So we're x over y. So now we are going to be undefined. At 45 degrees, we are going to be at +1. At 90, all right, we're going to be at 0 because 90 is 0, 1. And when we're doing x over y, we get 0 over 1, which simplifies to 0. 135, so that's in our second quadrant, all right? So we have the square root of 2 over 2, square root of 2 over 2, but in this case, the x is negative, so we end up getting -1. And then at 180, which is our -1, 0, we end up with undefined. Okay, so as you can tell, we are going to have a little bit different of a graph here. All right, because our first asymptote for cotangent is actually at 0, which would be nice if it was like that for tangent, but it's not, so it is what it is. Okay, so we have 0 degrees, and then 1, 2, 3, 4, and then this is 180. So that's our next asymptote, right? So then this is 45, this is 90, and this is 135. All right, sketching in our asymptotes, we have bam, 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 bam. Hope you guys like my sound effects. I like to do them. So those are our asymptotes. All right, so at 45, we are, oh, I didn't even label my y-axis. So we have +1 and we have -1. So we are here, and then 0, and then -1. So here is our beautiful cotangent graph. All right, so like you can see, and cotangent, just like tangent, does continue in both directions, right? So it does continue to do these little cotangent curves all the way off the graph, but we don't actually care about that. We want to find one section of the graph that covers all of the positive and all of the negative values and doesn't repeat anything. Well, just like with tangent, between our asymptotes, it does that for us. So if we look right here, this little section of our graph is going to do all the things we need. It hits our highest point, it hits our lowest point, and it passes both a horizontal and a vertical line test. So this is the section that we're going to use for our inverse cotangent graphs, which means for our restricted domain, we're going to be looking at it from 0 to 180 degrees, which is the same as cosine and secant. So tangent and cotangent do have different restricted domains, which kind of sucks, but it is what it is. So let's really quick review our different, there we go. All right, so let's real quick review our different inverse functions. All right, so we're doing all of them. So here I have our unit circles. Okay, so the first picture we have, the restricted domain is from -90 to +90. I'm gonna zoom in again because it's just easier. There we go. Okay, so we have -π/2 to +π/2 or -90 to +90. This is quadrants 1 and 4. All right, so the functions that we're gonna have inverse values coming out of these two quadrants are gonna be sine, so inverse sine, inverse cosecant, and tangent, or inverse tangent. All right, so those three inverse functions have values that come out of this restricted domain, this interval from negative pi over 2 to positive pi over 2. So quadrants 1 and 4. All right, the other option is having the restricted domain from 0 to 180, meaning we're pulling values from quadrants 1 and 2 when we do inverses. And on that side, that's going to be our inverse cosine, our inverse secant, and our inverse cotangent. All right, so all of those inverses pull from quadrants 1 and 2 on our unit circle. So remember, all of this is unit circle. So the better you get those things memorized, the easier this really does get. Okay, so let's do a couple examples. We have some unit circle examples, and then we have some non-unit circle examples. All right, so we're going to do all of them, right? Okay, so number one, we have our unit circle. So we're going to start on the inside. So remember, these are composition functions, meaning a function inside of another function. All right, so arctangent of square root of 3, square root of negative 3, sorry, missed the negative. All right, so remember, tangent, these values are coming out of quad 1 and 4. 1 and 4. All right, so what angle in quadrants 1 or 4 has a tangent value of the negative square root of 3? Well, the negative tells me it's quadrant 4. All right. So now I just have to figure out which angle. So the square root of 3, this is either going to be your pi over 3s or pi over 6s, or 30 or 90 degrees, right? Because they're the only angles that have a square root of 3. So we need to figure out which one this is. All right, so for tangent, I know that that's y over x. So basically what I'm going to do is just pick one, because I don't have the tangent values for my unit circle memorized. I just have my x and my y points. All right, so I'm just going to pick one. I'm going to pick 30 degrees just because it's the one that comes first. So for 30 degrees, my y value is 1/2 over my x value, which is square root of 3 over 2. And now I'm just going to simplify and see if this was the right option. So flip and multiply. So that simplifies to 1 over root 3, which is root 3 over 3. All right, so the tangent of 30 degrees is the square root of 3 over 3. So that tells me that 30 degrees is not the angle that I'm looking for because it doesn't have the right tangent value, which means by default, the only other angle that has the square root of 3 in it is 60. So that means that arctan negative square root of 3 is going to be negative 60 degrees by default. All right, so this is negative 60 degrees. All right, so now I'm going to bring down the sine and finish up the problem. So now I want to know, what is the sine of negative 60 degrees? Well, sine is my y-coordinate. At negative 60 degrees, my y-coordinate is the negative square root of 3 over 2. So the answer is negative square root of 3 over 2. That's my final answer for the problem. So like right here, I would put negative root 3 over 2. Okay, moving on to number 2. So this one has the inverse on the outside. So we still start on the middle. All right, cosine of pi. All right, so this is asking me, what is the cosine of pi? Cosine is our x value. At pi, our x value is negative 1. So now I'm going to find the angle, the angle that has a cotangent value of negative 1. Now cotangent, this is going to have inverse values pulling from quadrants 1 and 2. Since it's negative, I know that I must be in quadrant 2. All right, so I'm looking for an angle that has a cotangent value, which cotangent is x over y, that simplifies to negative 1. These are going to be your 45-degree angles. So in the second quadrant, my 45-degree angles, or my pi over 4 angles, are 3 pi over 4. So 3 pi over 4 is my angle that has a cotangent value of negative 1. You could have also put 135 degrees. right? I would probably say 3 pi over 4 since it gave me my first thing in radians that we would want to stay in radians. So by instinct, I would have said 3 pi over 4. But if you put 135, I wouldn't count it wrong. All right, moving on to our non-unit circle. All right, so we only have one example here, so I just chose to do a tangent problem or inverse tangent one. I didn't do an inverse cotangent, but I think you guys get the point for the most part with these ones. I think these ones generally tend to be easier than the unit circle ones. But first thing we're gonna do is we're gonna sketch our triangle. Now, tangent, inverse tangent comes from either quadrants 1 or 4. So when I draw my triangle, I'm either gonna draw it in quadrant 1 or quadrant 4. This is a negative value, which tells me that I am in quadrant 4. So here's my 4th quadrant triangle. All right, and tangent, which is opposite over adjacent. So opposite is negative square root of 5 and adjacent is positive 7. So now I need to do the Pythagorean theorem to figure out what the length of my hypotenuse is. So I have 7 squared plus negative root 5 squared equals my hypotenuse squared. All right, so that's 49 plus 5. So 54, is there any perfect squares that go into 54? 9 does, right? 9 and 6. So yeah, so we have, so hold on, this becomes 54 equals h squared. Take the square root of both sides. And like I said, this simplifies to 3 root 6, and there's nothing else I can take out of 6. So that is my hypotenuse, 3 root 6. All right, now I can answer the final question, which says, what is the cosine of this triangle, right? So of this angle, what's my cosine value? So cosine is adjacent over hypotenuse, so 7 over 3 root 6, multiply top and bottom by the square root of 6 to rationalize, and I have 7 square root of 6 all over 18. That is my final answer to my problem. So that is the cosine of the triangle with this tangent value. All right, I hope that was helpful, and I will see you guys in our next video. Bye.